In order to understand a t-test, I want to go through a PowerPoint presentation that was put together by another IB teacher, and I think it does a really nice job explaining it. So here we go. Um, the real question you want to address with a t-test is, are the results reliable? And so you're going to look at two different groups of data, and you're going to determine whether or not there's a significant difference between the groups of data. So let's say we're looking at two classes of students, class in yellow and class in orange. We're going to compare their heights to see if there's a significant difference between the height of the class in yellow and the height of the class in orange. And so we pull out a pupil and we measure their height from each class. We determine that one pupil is taller than the other. Why could that be? Well, there's a number of explanations for this. One reason would be that there is a significant difference between the two groups. For instance, if they're in 7th grade in the yellow class, but the orange class is in 11th grade, then we would expect there to be a significant difference in their heights. A second reason could be that we randomly picked a person that happened to be short from the yellow class and a person that happened to be tall from the orange class. Maybe they're both from the same grade. Maybe Titch is a 9th grade student and Haggard is a 9th grade student, and we just happened to get one that was short and one that was tall. So how can we tell which reason is most likely to occur? We have to measure more students. So if we're going to try and determine if there's a significant difference between the groups, we need to measure and determine the mean or average height of the two groups. So if there is a significant difference between the two groups, for instance, if they're different aged students, then all of the students should average to a different height in each of the classes. If there's no significant difference, then we would be able to determine that the mean height of the two different classes would be about the same, right? There'd be very different or very small difference between the two groups. So it's important to remember that we're studying biology, and that in biology it's the study of living systems, and there's always a lot of variation in living things. So it's really unlikely that we're going to have the exact same average for any two groups of data, right? So here's the average height for the yellow class, and here's the average height for the orange class. This leaves us with the question is, if they're only different by 6 centimeters, is that a significant difference enough to say that there's clearly a difference between the two groups? So this is where we go into some data analysis. We could plot the samples and see that the height of the yellow versus the height of the orange. We could look at the ranges and see if there's an overlap in the range, but there's not a whole lot of overlap. If you notice, the overlap occurs here in the 160 to 169 range. Other than that, the two groups don't really overlap very much. In this example, the samples have a lot of overlap. So here, all of the data within the range has some overlap. So we're going to try and use a t-test to determine whether or not there is a significant difference between the two groups. Right? So we have to look not just at the mean, but also the spread. And the spread of the data means we're looking at the range of the data, the average value of the data, and we're looking at how much variation there is within the data. So that's the mean, the spread, and the standard deviation. We learned a little bit about standard deviation in a previous lesson, and you can go back to that one if you'd like. This is the equation for standard deviation. And hopefully you're familiar with how to do standard deviation calculations. If you're not, just send me a message that says, hey, let's meet up and talk so that we can, and I can explain that to you. We're going to move forward to the t-test. So standard deviation is part of the t-test, but it's not the entire thing. To calculate the value t, we use the following equation. And in this equation, I want to define the terms. X bar 1 is the mean of the first sample. X bar 2 is the mean of the second sample. S1 is the standard deviation of the first sample. N1 is the number of individuals that you sampled in the first sample. S2 is the standard deviation that you calculate for the second sample. And N2 is the number of individuals in the second sample. So let's look at the class of students. Here's the data table that we could have generated from looking at the students. The height is measured in centimeters, so the students in group C1 their heights are here, and the students in group D8, the heights are here. The first thing we need to do is determine the mean height for each sample. So we're going to add up all of those values and divide by the total number of values in the sample. X bar 1 refers to the mean or the average value of the first sample, and we determined that it is 161.60. The average of the second sample is 168.27. The second step is to figure out the difference between the means. So we subtract the means, subtract x1 from x2, and we determine that the difference in the means is 6.67. That's going to be our numerator in our equation. The third step is to figure out the standard deviation for each sample. And again, if you need some help doing this, we can go back and review that. The standard deviation for the first sample is 10.86. The standard deviation for the second sample is 11.74. We then have to square that standard deviation and divide by the number of values in each sample. So for the first class, we take 10.86 squared and divide by the number of students that we sampled, which was 15, giving us a value of 7.86. For the second class, we do the same thing. We square the standard deviation value, which was 11.74, and we divide by the number of students that were sampled, which was 15, giving us 9.19. Finally, we need to calculate the square root of the denominator. So we take the square root of those values added together, which gives us 4.13. We now have our denominator. We have the numerator, which was the difference between the means. We have the denominator, which is the square root of the terms in the denominator. And we can calculate t. It's simply step 2 divided by step 5. So we end up with a t value of 1.62. We can practice this individually. I'm going to give you some problems you can use to test your understanding of this, but if you follow these 6 steps consistently, you should get the correct answer every time. So, unfortunately, that value in and of itself doesn't tell us enough information, so we have to figure out how to interpret that value, and that's what the remaining steps will tell us. In step 7, we're going to figure out the degrees of freedom. Degrees of freedom refers to how much variance we can allow within a given set of data. And for a t-test, to determine the degrees of freedom, it's the number of sampled individuals in the first group plus the number of sampled individuals in the second group minus 2. So in each group we sampled 15 students, so that's 15 plus 15 minus 2, which gives us 28 degrees of freedom. We're going to use critical values tables, which you can Google. If you go on Google Images and you type in t-test critical value table, you'll see there will be a chart which tells us if you use the number of degrees of freedom and you use a confidence limit, which I'll explain to you in class, called P.05, you can determine that the critical value is 2.48. And when you're referencing the critical value, it is always a point of reference to your calculated value. Now, in this example, our calculated value for t was below the critical value, so there is no significant difference between the heights of the students sampled in the classes. If you do analysis where your t-value is larger than the critical value, then there is a significant difference between the two groups. But in this example, we found that our calculated value was below our critical value, therefore there was no statistical difference between the two groups.